when Ukrainian pilot Andriy Pirshtchikov warned his comrades in his final radio communication before his death that Russian long-range missiles have turned the sky into a death trap, he likely did not anticipate that just a few months later, the boundaries of this death trap would be further expanded by a new weapon codenamed Product 180. In late July 2025, debris from a trapezoidal tail-fin missile mounted under the wing of a Su-35S fighter jet circulating on social media, along with metal components with truncated crosswings recovered from the Ukrainian front lines, collectively confirmed a new battlefield variable. The Ir-77M medium-range air-to-air missile had been deployed in combat. This weapon, dubbed the Russian version of the Lightning 15 by the West, not only embodies Russia's ambition to reclaim its air superiority, but also quietly rewrites the rules of beyond visual range air combat amid the smoke of the Russia-Ukraine conflict. The development of the Ir-77M is essentially Russia's arduous attempt to address a technological gap from 3 decades ago. Its predecessor, the Ir-77, was developed during the final years of the Soviet Union, with the aim of competing with the US AIM-120. However, due to the financial collapse following the end of the Cold War, it was only reluctantly put into service in 1994, with limited production quantities. The early models' grid-like tail fins, which resembled kitchen tools, when deployed, were jokingly referred to as potato mashers. While this design reduced folding dimensions, it increased drag and radar cross-section, leading to frequent mechanical failures in combat. The Ir-77M's innovations began with wing reduction, replacing the grid-type rudder with 4 trapezoidal carbon fiber composite tail. Fins improved aerodynamic efficiency by 30%, reduced the radar cross-section to 1/5 of the original, and more importantly, met the physical constraints of the Su-57 stealth missile bay. The upgrade of the propulsion system is even more strategically significant. The introduction of a dual-pulse solid rocket motor enables the missile to regulate thrust in a breathing manner. The first pulse boosts it to supersonic cruise speed, while the second pulse ignites in the terminal phase, ensuring it maintains a high kinetic energy of over Mach 4 upon impact. The Russian side claims a maximum range of 190 kilometers, a figure derived from tests targeting high-altitude targets at 1.5 Mach. However, when converted to the 1.2 Mach target standard, commonly used by China and the United States, the actual effective range is approximately 100-120 kilometers. Even so, this already surpasses the 74-kilometer maximum range of Ukraine's currently deployed AIM-120C5 missiles, forcing Ukrainian aircraft to expose themselves to Russia's kill chain before entering their own fire range. The guidance system technology remains a point of contention. Russia claims the Ir-77M is equipped with an active phased array radar, but analysis of existing debris suggests it may employ a hybrid, active-passive composite guidance mode. Passive mode to receive enemy radar waves for stealthy approach, then switch to active radar lock-on in the terminal phase. This represents a generational gap compared to the PL-15's pure gallium nitride ESA radar, which offers a 40% improvement in detection accuracy and anti-jamming capabilities capable of penetrating the F-35's onboard electronic warfare shields. However, Russia's production of onboard radars for the Su-57 remains stalled, and its ability to mass-produce missile-grade miniature ESA radars is even more questionable. The operational deployment of the Ir-77M marks the completion of the Russian military's high-altitude hunting system. Su-35 squadrons patrol at 15,000 meters altitude, using the Snow Leopard E radar to detect targets 400 kilometers away. They first target high-value assets like early warning aircraft and refueling aircraft with the 400-kilometer range or 37M. Then, after enemy fighters evade, use the Ir-77M to cover a 70 to 150 kilometer airspace, forming a dual-fire network. The Ukrainian Air Force has little defense against this. Its F-16M and Mirage 2005 fighters are tracked by Russian early warning systems as soon as they take off. If they climb to evade, their fuel reserves deplete rapidly. If they attempt low-altitude penetration, they fall into ground-based air defense fire zones, leaving their survival window compressed to a dangerous level. The Ir-77M has allowed Russia to barely join the Big Four club of beyond visual range missiles, but China and the US have already begun competing for dominance in next-generation technology. China's PL-15, the domestically developed version, has a range exceeding 200 kilometers. After optimization, the J-20's missile bay can now carry 6 missiles. Its reconnaissance control strike system reduces the intercept chain reaction time to 90 seconds, forcing the US military to accelerate the development of the AIM-260, US AIM-260, equipped with a dual-mode ramjet engine, With an estimated range of 250 kilometers, it prioritizes enhancing cooperative engagement capabilities, enabling the F-35 to share radar target data from carrier-based radars. Russia's dilemma. The Ir-77M's 190-kilometer range relies on ideal testing conditions, with actual combat effectiveness reaching only 60% of the PL-15's performance. More critically, the Su-57's annual production is less than 10 units, making it difficult to form a system-level capability. Missiles may remain mounted on non-stealth platforms like the Su-35 for the long term, weakening penetration capabilities. Europe has clearly fallen behind in this round of competition. While the Meteor missile's ramjet engine maintains high-speed advantages, its seeker head remains a mechanical scanning radar, lagging a generation behind in anti-jamming capabilities. While the UK's Spear 3 missile development is behind schedule and will not be operational before 2028. Emerging powers are quietly rising. Turkey's Sky Storm missile is compatible with the F-35's missile bay, combining domestically developed ESA radar with ramjet propulsion. With a range of 185 kilometers, gradually eroding the traditional military trade market. The greatest challenge for the Ir-77M lies not in design but in engineering implementation. Russia's microelectronics industry has been severely impacted by sanctions, with the yield rate of gallium nitride power components required for ESA radars below 30%. The N-036 Squirrel radar for the Su-57 has an annual production of only 15 units, and the missile seeker head requires components to be reduced to one-fifth of their original size. Wreckage from the front lines indicates that early batches may have used the 9B1103M guidance head from the Ir-77-1, whose mechanical scanning radar is prone to losing targets under strong electromagnetic interference. Material bottlenecks for the dual-pulse engine are equally prominent. During the second pulse ignition, the combustion chamber temperature exceeds 2000 degrees C, requiring a rhenium-nickel superalloy lining. However, Russia's domestic rhenium production accounts for only 3% of global output, and Western embargoes have forced it to source from China, where insufficient purity has led to a sharp decline in engine lifespan. This stands in stark contrast to the PL-15. China accounts for 46% of global rhenium production, and has mastered single-crystal turbine blade technology, ensuring the stability of missile mass production. Even so, the symbolic significance of the Ir-77M far exceeds its tactical value. It demonstrates that Russia retains its military-industrial upgrading capabilities even under extreme sanctions. Its design logic also reveals the core trend of future air combat. Missile range and cyber warfare capabilities are replacing the number of fighter jets as the new pillars of air superiority. Through missile asymmetric upgrades, the Russian military has narrowed the generational gap between fourth-generation and fifth-generation aircraft to the same firepower dimension, providing a cost-effective air defense solution for global middle powers. As the Ir-77M's exhaust trails across the skies of Donbas, it ignites not only propellant but also a covert battle over the definition of air combat rules. This missile bridges Russia's 30-year technological gap, but fails to overturn the smart missile order, dominated by China and the United States. The human-in-the-loop system of the PL-15 and the cloud kill chain of the AIM-260 are ushering air combat into an era of algorithmic confrontation. In the coming decade, what determines the ownership of the skies may no longer be the numbers on the range table, but the decision-making speed of artificial intelligence-guided heads, the penetration probability of hypersonic glide vehicles, and the bandwidth limits of cross-domain data links. In this silent revolution, the Ir-77M is Russia's desperate attempt to regain its dignity, but it is merely a single note in the prelude. The true turning point will quietly take shape between the beams of gallium nitride phased array radars and within the bit streams of quantum encrypted data links.